So when we do this, we need to specify the probability of a type 1 error. So remember that the type 1 error happens when we reject the null hypothesis and accept the alternative hypothesis when actually the null hypothesis is the true one. So we want to make sure that the probability of a type 1 error is small enough. So we use this and we call this the alpha value. And the alpha value is commonly 0.05 or 5%, or we can even take the alpha value as 1% or 0.01. Okay, so those are the two common ones, but you can use anything you want here. So, but we want to make sure that these are relatively small. We don't want to be making type 1 errors all the time, so we need to choose an alpha that's sufficiently small. So what do? We need to calculate the z, the test statistic. And we use this z value if we know the standard deviation of the population. So we can calculate that this way, where we take our mean of our sample data, subtract it off the mean that we're testing, and divide that by the standard deviation or the standard error. So this value down here is the standard error. That's the standard deviation divided by the square root of the number of samples that we have. So how do we know once we calculate this z value if we need to reject the null hypothesis or we do not reject the null hypothesis? So it really depends on the situation we have. The one I just went over, we have mu is not equal to this value. So our value is not equal to that 1.5 inner diameter of the bearing. Okay. So we reject the null hypothesis if our value that we calculate for z is less than this value here, where we insert alpha into this and we look up this value in the table, or z is greater than this value we look up on the table. So we would reject the null hypothesis if either of these are true, and we would accept the alternative hypothesis. And I know that this is kind of confusing right now, but hopefully we can clarify this with a few examples.